Hello class. I'm going to do a YouTube video of chapter 4 with you. I'm going to review from the beginning, even though we've done some of it before. Take it from the top and go all the way through to the end so you'll have something to review in preparation for our test. So if you remember, chapter 4 is tissues. I have the PowerPoint up in front of me and I'm going to go slide by slide. I'll let you know what slide I'm on, what I'm talking about, so you can follow along. So I'm at the beginning, and it says chapter 4, tissue level organization. So we're talking about the 4 tissue types: epithelial, connective, muscle, and nervous. Most of our emphasis is on epithelial and connective tissue. Muscle we have a special chapter on, and nervous we have a special chapter on. So we'll do those in more detail at a later time. Okay, I'm skipping through to slide 4. It tells you the definition of tissue. Specialized cells working together as a group. We've talked in detail about that. And we know that tissues, the 4 different types, are blended together to make the different organs of the different systems. And we talked about the definition of histology, which is basically the study of tissues. Okay? You know the 4 types: epithelial, connective, muscle, nervous. Slide 6. It tells you a little bit about what an epithelial tissue is. You know that it's used to cover and line different structures of the body, covering like our skin, lining like the serous membrane of the ventral body cavity. Also, epithelial is used to form glands. So when you cluster them together, like a cluster of grapes, you create glands that produce secretions. Connective tissue, wide variety of stuff, as you know. Many different types of connective tissue with many different functions. We'll look at the functions as we get to it. Next slide. Muscle tissue, you know, is for contraction, and there's 3 different types: skeletal, cardiac, and smooth. And nervous tissue for communication. Nervous tissue, the neurons, carry information to the brain and from the brain, letting body parts know what to do, when to do, maintaining homeostasis, and many high-level functions. And we'll talk about those in more detail in the nervous system chapter. Okay. Slide 8 gives you just a beautiful overview, a good slide to just put all the pieces together. Again, the hierarchy starting with cells, going up to organ systems. Okay. Slide 9 looks at some details of epithelial tissue. Okay, so slide 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, all describe characteristics of epithelium. Okay? And we've discussed a lot of these things, some of the terminology that's used to describe epithelium. I'll slide back a bit, give you some of those terms. Okay? Polarity, cellularity, attachment, avascularity, and regeneration. These are from slide 11. And we defined each one of those, what each meant. Quick definition: polarity means that the cell, the epithelial cell, whether it's a squamous, a cuboidal, a columnar, they use columnar as their example, has a top and a bottom, an apical surface and a basal surface. In addition, they have a lateral surface, especially cuboidal and columnar. Cellularity, the cells are tightly bound to one another. And we talked about how. Using proteins, using glue. And we went through different types, like a tight junction, or a desmosome, or a gap junction. And then we also looked at something called a hemidesmosome. And this is where the cell attaches to the basement membrane, meaning all epithelial cells at the basal surface of the lowest level of cells, you're going to find a chemical glue containing some proteins known as the basement membrane. And the cells are attached to the basement membrane via the hemidesmosome. So when we talk about attachment, we talk about not only how the cells are attached to one another, but how they are secured to the basement membrane. Avascularity means epithelial cells do not have blood vessels, capillaries, woven between the cells. And regeneration, these cells are able to undergo mitosis and regenerate and replace damaged cells. So that's what's contained in these slides that I just mentioned. So I'm skipping through them because we talked about much of that already. I want to get to some new terminology. So I'm going to slide 27, and slide 27 is where they describe the shapes of epithelial. And we went through these details also. Squamous, cuboidal, columnar, the shape, whether it's simple, one layer, or stratified, multiple layers. And what follows, of course, are those beautiful little picture boxes that have the different types of epithelium. And there's 8 types, as you know. 6 of them are the most common, right? A simple squamous, a stratified squamous. A simple cuboidal, a stratified cuboidal. A simple columnar, a stratified columnar. With the other 2 being a pseudo-stratified columnar, which typically has cilia, and something called transitional, a cell that changes shape. And we went through these slides, 27 and onward, discussing different places where the epithelial can be found and the reasons why they're there. We talked about the definition of mesothelium that lines body cavities like the serous membrane. Endothelium, which lines the chambers of the heart and the blood vessel. We talked about all the different types and where they're found, and you will find on slide 31, simple squamous epithelium, a picture, a discussion of its function, different locations, and you'll be reviewing these as you have been all along. But again, remember, something simple means that it's there so that movement, transport can take place, meaning something on one side of the cell can be moved through the cell to the other side, what we call absorption, okay, or resorption. We find these in areas where that's important. Simple, one layer, as compared to something that's stratified, many layers, where movement, transport through the epithelial layer is not important. It's more of a protection mechanism. Simple cuboidal, stratified cuboidal, slides 33, 34, 35. Then we have transitional. Transitional epithelium means the cell changes shape. And we have the little explanation box on 37 letting us know. Empty bladder, full bladder. Empty bladder, they tend to be more of a cuboidal columnar shape. And then as we fill the bladder with urine, where urine is stored, the cells change shape. They become more squamous, more cuboidal, changing shape. Right? They can go on to 38 and 39 and 40, talking about simple columnar, pseudostratified, stratified. Okay, 39 is the simple columnar, again important in the lining of the digestive tract. These have microvilli, again to facilitate absorption, secretion, movement from the gut lumen into the blood vessels below in the loose areolar connective tissue. Remember, loose areolar connective tissue is always found beneath epithelium. It's where the blood vessels that supply the epithelial cells with oxygen and nutrients is found. Pseudostratified ciliated, we had our discussion about the lining of the air passageways, the cilia, and how it can be destroyed with smoking, so on and so forth. That's a discussion we had. Stratified columnar, salivary gland ducts, and so on. Okay? When you get to 42, it starts to talk about the glandular epithelium. The glandular epithelium are the clusters of cells that are specialized to produce secretions. We talked about the difference between endocrine gland and exocrine gland. Endocrine, direct secretion into the blood, no ducts, produce hormones, and that's a whole system unto itself that we'll talk about in the next class. Exocrine, produce secretions, have ducts, scattered throughout the entire body. Okay? And they go on to show you different shapes and different configurations of how the glands can be made, how the cells are arranged. Remember, there is one specialty, right? It's that unicellular exocrine gland. The unicellular exocrine gland is the gland or goblet cell that produces mucus. Okay, it's a single cell that produces mucus, and that mucus is then released onto the surface of the epithelium. So they go through that on 43. They talk about multicellular exocrine glands, which is most of them, and the different shapes and structures. And I mentioned to you that you do not have to memorize each and every shape, but you can look at the pictures. 47, 48, 49, 50, 51, 52. These are the slides that talk about how exocrine glands create secretions, meaning the merocrine, the apocrine, the holocrine. Merocrine are typical creation of secretory vesicles releasing this secretion via exocytosis. Apocrine, having the collection of secretory vesicles in the apical part of the cell, and the apical part of the cell breaks off. And holocrine, collection of secretory vesicles within the cell, the entire cell is destroyed. And they give you examples of where you would find each one of these. They give you pictures, right, of the merocrine, and they talk about salivary glands. And the apocrine, they talk about mammary glands. And for the holocrine, they talk about the sebaceous glands, the oil glands of the skin. And I'm just looking at the pictures as we go through. You'll have those to look at. Okay? 53 is not telling us much. It's just telling us that the secretions that can be produced by exocrine glands can be watery, can be thick like mucus, can be a little of both. Okay? 54 begins our discussion of connective tissue. And in connective tissue chapter, what do? We start off by defining connective tissue, meaning 3 components must have specialized functional cells that live within a ground substance, and intermingled between the cells are protein fibers. If you have those 3 things, you have a connective tissue. Also, the word matrix. The matrix is the ground substance plus the protein fibers that the cell lives in. So cells live within the matrix. With regard to functions, we're leaving that for the specific types, because bone, ligament, tendon, adipose, areola, they're all in this chapter, and each one has a different function. So we'll define the functions as we define the tissues. Okay. We put on the board a little schematic, because connective tissue is a big family. We have the connective tissue proper as one of the subfamilies. Is that better? We have fluid connective tissue. We have supporting connective tissue. Now, the connective tissue proper is the largest group. Fluid connective tissue has the blood and the lymph. Supporting connective tissue has the bone and the cartilage. So they deal with connective tissue proper first. And of course, they define what loose means and what dense means. All right, so there's a bunch of loose connective tissue proper, like areola, adipose, and dense connective tissue proper, like tendons, ligaments. Loose means the cells are spread out with a lot of ground substance in between. Dense means that the cells and protein fibers are tightly packed, creating a stronger tissue. Okay. Slide 58 shows you all the different cell types. Not every cell type found in every connective tissue, but many of the cell types found in connective tissue proper. And we went through the discussion of the fibroblast and the fibrocyte, what an adipocyte is, what a melanocyte is. Then we talked about mesenchyme, the stem cells that give rise to all these different types of cells. We did a little discussion of white blood cells, macrophages, microphages, lymphocytes, mast cells. We talked about healing and repair and how mast cells and some of these other macrophages and microphages play a role. So 59, 60, 61, 62, they talk about the different cells. Okay. 63 talks about the 3 different types of protein fibers. Collagen, the most abundant. Reticulate, which forms like a mesh or net or fishnet. And elastic, which are like rubber bands. And it describes collagen on the next slide, 64. Most common, strong, flexible, resist force in one direction, found in tendons and ligaments. You can stretch it, it's pretty strong, but it does have a limit. If you go past the limit, you can tear it. Unlike elastic, which is truly like a rubber band. Stretch it, it returns. Stretch it, it returns. A lot of elasticity, of course, and in some areas of the body, we require that. In other areas of the body, like tendons, ligaments, we don't need as much elasticity. We need more strength, resiliency. Okay? 65 talks about reticular fibers, and they form a net. And we talked about the fact that they are used to make the framework of solid organs. So if you want to build a liver, a kidney, a lymph node, the spleen, even in the bone marrow, you start with the stroma, the reticular fibers interwoven like a net, and then you place the functional cells, the parenchyma cells as we call them, on the net. So the reticular fibers become the foundation, the skeleton of the organ. Then we place the cells of the organ on the stroma, on the network of fibers, and then typically we cover it in a capsule. And 66 is elastic fibers, and it tells you that they are like rubber bands. They stretch and return to their normal size. 67 is that fantasy picture of all the cells, the 3 proteins in a pink ground substance. There is no real tissue like this. The closest thing to it would be a loose areola. They talk a little bit about ground substance on slide 68. It's for connective tissue proper. They say clear, colorless, viscous, so it's slightly thick like honey. And then they go into, again, all these beautiful picture boxes, starting with slide 69, describing the different types of connective tissues and what they're used for and where you find them. And they begin with mesenchyme and mucous connective tissue, and we talked about the fact that those are embryological. They're found in the embryo. They give rise to the other mature tissue types. So we have mesenchyme on slide 70. We have mucous connective tissue on 71. Then we go into some of the mature types. On 72, it names the 3 types of loose connective tissue: areola, adipose, and reticular. And they talk about on 73, areola connective tissue. That's always found beneath epithelium. And it's open space where you can put blood vessels, where you can put nerve fibers, sensor receptors, and those things are what supply the epithelial tissue above. And they give you a nice picture box, and they show you an example of areola. They talk about where you would find it. And these are the picture boxes that we were looking at and what you want to continue to review. Look at the box, look at the tissue name, areola tissue. Look at some of the locations. What does it say here? Found in the skin, under the epidermis, found throughout the body, okay? They say digestive, respiratory, urinary, muscle tissue, so on and so forth. But again, we've always talked about areola as being the support cells for epithelium. Adipose, 75 and 76. They talk about adipose tissue. So these are adipocytes, that's the functional cell. It is found throughout the body, once again, surrounding organs, in certain areas of the abdominal cavity, in what we call the greater omentum, that would be belly fat. Adipocytes store triglyceride, excess calories that become stored as triglyceride. And they give you some information about adipose tissue. They talk about two types, white fat, brown fat. We're on slide 76. White fat is the common fat you think of in the body. Brown fat is a slightly different type of fat found in newborns and young children. It has more blood vessels, it has more mitochondria, it makes more energy and therefore generates more heat, and it helps to keep the newborn's body warm. And then they give you the picture box, and the picture box describes and shows you slides of fat and tells you where you find it throughout the body. Reticular tissue, that's the third type of loose connective tissue, and again, we talked about that just moments ago. Reticular tissue is characterized by reticular protein fibers. Reticular protein fibers form a net, form a foundation, form a skeleton for solid organs: liver, kidney, spleen, lymph nodes, bone marrow. And then we place the functional parenchymal cells on the network and then cover it in a connective tissue capsule. And then you get your little picture box, and they're using the liver as their example. Then it goes on to dense connective tissues. We're up to slide 80. I'm going to pause the video now, and we'll do it in another part.